Good afternoon and welcome to Mr. Nickelboro's Maths World. This is part 2 of finding the area enclosed by a parabola and the x-axis, where we don't know the equation of the parabola. Now this might be slightly ambiguous, find the area enclosed by the parabola and the x-axis. This is the enclosed bit, the rest is open. So what I'm talking about is this tiny little area between where x is equal to 2 and x is equal to 3. In this problem, what makes it a touch different from the part 1 is that we're not going to be able to make use of the idea of symmetry so much. But we can say this, we can say that y is equal to, now we know what the x-intercepts are. They are 2 and 3, so we write -2 and -3 there. And we still need to discover what a is. And the good news here is that we follow the same procedure as before. That is to say, when x is 0, we know what the value of y is. It is the y-intercept. So when x is 0, y is going to be the value of the y-intercept. Here, I put it in red, it's 36. So we can say that 36 is equal to a. When x is 0, we've got -2 times -3. Okay, so therefore 36 is equal to -2 times -3 is 6. 6 times a is 6a, therefore a equals 6. So our equation turns out to be this. Okay? Alright, so now we need to find the area, and there shouldn't be too many mysteries in all of that. So, the area, now unfortunately we can't rely on symmetry, but we do know what the limits are, and they are 3 and 2. We're going to put our scalar out the front, so 6, and we have not a difference of 2 squares in fact, but a quadratic expression there that would need to be expanded. So using FOIL, first, outer, inside, last terms, that technique or otherwise, we can see that it's going to expand to x squared. Let's think a bit here. It's minus 3x and then minus another 2x. So it's minus 5x and the last term is plus 6 and we are integrating in respect of x. Okay, so that means that the area, now we can do the calculus. There's no problems about that, and it's the usual story. X to the power of 2 goes to x cubed on 3, so you increase the index by 1 and divide by the new index. That goes to 5x squared on 2, and to integrate the constant you simply add an x, and our limits were 3 and 2. Okay, so over here we go. What do we have? Well, 6 area equals 6 times, I'll use square brackets at the moment, I'm not sure I need them, in fact I do. So, round brackets here, 3 cubed is 27, 3 cubed is 27, divided by 3 is 9, minus 3 squared is 9, 9 fives are 45, 45 on 2, and 6 threes are 18, and it's plus 18, and from that we need to subtract, substituting the 2 in, 2 cubed is 8, so it's 8 on 3, 2 squared is 4, times 5 is 20, so it's negative or minus 20 on 2, which does come to 10, I realise now, and plus 6 times 2 is 12, plus 12. Okay, so we are very nearly there, just tidying up. Therefore, A equals 6. Now what have we got here? We've got, let's keep the square brackets going. We've got 18 on 2. Minus 45 on 2, plus 36 on 2, minus 8 on 3, now this was minus 10 and that's plus 12, isn't it? Minus 10 plus 12 is overall plus 2, so it's 8 thirds plus 2. Now I'm going to call 2 6/3. Fair enough? And that was plus 6/3. Now that we have common denominators here, we've got area equals 6. Still square brackets. Not really. Rounded brackets. 6. Okay, what have we got? 18 plus 36 is 54. Minus 45 is 11. And it's positive 11 on 2. And minus...
Yeah, isn't that 9?
It's 9, sir.
So it's 9, is it? Where have I mucked up? 18 plus 36 is 54.
54 minus 45 is 9.
9. Very good. Thank you. So it's positive 9 on 2. Minus... Now, what have we got here? 14 on 3. Well, we'll just leave it as 14 on 3, won't we? 14 on 3. And therefore, running out of room, so you might have to do a bit of work on this. Let's convert these to sixths. That's the common denominator. Times that by 3 gets to 27. Times that by 2, 28. And the area equals, therefore the area, could I maybe put this up here now? The area is equal to negative 1 over 6, except we don't talk about negative areas, so it's going to be 1/6 unit squared. Okay, and that's our answer to that problem. Thank you.